limits involving infinity. This is the infinity symbol. This right here. The limit as x approaches infinity of the function f of x is equal to the limit, or the limit as x approaches negative infinity of the function f of x is equal to the limit. Limits at infinity describe the behavior of functions as the independent variable increases or decreases without bound. The function f of x is said to have a horizontal asymptote at y equals L. An example of this is the limit as x approaches infinity of 2 plus 1 over x. For this limit, to solve it, you have to plug in infinity for x. So once you plug it in, you have 2 plus 1 over infinity. Any number over infinity is 0. So to simplify, it equals 2 plus 0, which equals 2. This being said, it has a horizontal asymptote at y equals 2. This dotted line represents the asymptote y equals 2. These lines right here are the function 2 plus 1 over x. With the asymptote being at y equals 2, it will never pass over this line. It will never touch the y-axis, the asymptote, or the x-axis. The function goes to positive infinity, and this part goes to negative infinity. Welcome back, folks. I'm going to tell you about some limit theorems involving infinity, of course. Any number over infinity is equal to 0. If you apply the limit and it has a number over infinity, it's 0. And infinity over any number is equal to infinity. E to the 1 over infinity is equal to e to the 0 power, which is equal to 1. And then the natural log of 0 is equal to negative infinity. And the natural log of infinity is equal to infinity. And e to the infinity is equal to infinity. E to the negative infinity is equal to 1 over e to the infinity, which is equal to 1 over infinity. And if you folks remember, 1 over infinity is a number over infinity, which is 0. So, e to the negative infinity is equal to 0. And last, a number over 0 is equal to undefined or infinity. Now y'all better saddle up. I'm about to show y'all a few tricks of the trade to solving limits. The limit as x approaches infinity of 2x to the third minus 5 over 3x squared plus x plus 2. Now, one of my tricks of the trade is looking at your powers in the denominator. You take the highest power, which in this case is 2, and divide the numerator and the denominator by that power. So what you'll be doing is dividing the top and the bottom by x squared. And by doing that, you come out with 2x minus 5 over x squared over 3 plus 1 over x plus 2 over x squared. Now from this step, you must reapply the limit to your new function. 2x minus 5 over x squared over 3 plus 1 over x plus 2 over x squared. Step 3 is applying the limit by plugging in infinity to your x's, which will leave us with infinity minus 5 over infinity all over 3 plus 1 over infinity plus 2 over infinity. Now your fourth step is to simplify. Remember your limit theorems that I showed you just a moment ago. 1 over infinity being 0, 5 over infinity, anything over infinity is 0. So this will leave us with infinity minus 0 all over 3 plus 0 plus 0, which equals infinity over 3. And like our limit theorem says, infinity over any number is equal to infinity. Ta-da! Infinity! I'm going to show you that if the power in the denominator is higher than the power in the numerator, then the limit is going to equal 0. Let me prove it to you. The limit as x approaches infinity of the function 2x squared minus 5 all over 3x to the 4th plus x plus 2. As you can see, the power in the denominator, x to the 4th, the highest power, is greater than x squared. So let me show you how important this is. When you divide through by the highest power, as we did in the problem before, you get 2 over x squared minus 5 over x to the 4th. And the denominator divided by x to the 4th will be 3 plus 1 over x to the 3rd plus 2 over x to the 4th. Now once you've divided through by that highest power, you're going to reapply the limit to your new function. 2 over x squared minus 5 over x to the 4th over 3 plus 1 over x cubed plus 2 over x to the 4th. Step 3 is reapplying that limit by plugging in infinity into your x's. 2 over infinity minus 5 over infinity all over 3 plus 1 over infinity plus 2 over infinity. Now as you can remember from our theorems, any number over infinity is equal to 0. So this is 0, this will be 0, and so will these two. So step 4 will be simplifying. 0 minus 0 all over 3 plus 0 plus 0, which simplifies to 0 over 3. Now as I said before, if your highest power in the denominator is greater than the highest power in the numerator, as in x to the 4th being higher than x squared, it will equal 0. So that leads me to my ta-da, which is 0. If the highest power in the denominator is the same as the power in the numerator, the limit will be the first two constants. Act like this right here ain't there. It's 2/3. Now let me prove it to you. step 1 will be dividing through by the highest power in the denominator, which is x squared, which will leave you 2 minus 5 over x squared all over 3 plus 1 over x plus 2 over x squared. Now, step 2 will be to reapply your limit to the new function. As you can see, 2/3 is still in the front. The new function is 2 minus 5 over x squared over 3 plus 1 over x plus 2 over x squared. Now, step 3 is going to be plugging in that negative infinity to every x. So 2 minus 5 over negative infinity over 3 plus 1 over negative infinity plus 2 over infinity. Now, as I've already told y'all, any number over infinity is equal to 0. Now, this is going to end up being 2 minus 0 over 3 plus 0 plus 0, which leads me to my ta-da, which is 2/3, which is what I told y'all in the beginning. Now, that's funny. I don't care who you are, that's funny right there. Thank y'all so much for sitting through this. I know it probably got annoying, but how else do you make Calculus 3 interesting? That was my problem, and this is how I dealt with it. And that was my version of limits involving infinity. This is Buzz Lightyear, and he knows something about infinity. Are you ready? Alright, can you say to infinity and beyond? You gotta put your arms out. Woo! To infinity and beyond. Alright, can you say bye? Bye. Can you say to infinity? Hey, Brody. Hey, Brody. Hey, throw me one more kiss and say love. Say bye.